Welcome. The ITRC Passive Sampling Update team is proud to present an overview of the Waterloo membrane sampler technology. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Waterloo Membrane Sampler, or WMS, is an accumulation-type passive sampler. It is primarily used to sample indoor air, outdoor air, and soil gas. The sampler is a tube-style permeation passive sampler, with a thin hydrophobic membrane that covers the sorbent-filled vial. Within the vial, the sorbent used can either be a very strong sorbent, like a charcoal type, which requires solvent extraction for analysis, or a weaker sorbent, like graphite carbon black type, that is amenable to thermal desorption. When the device is deployed to the environment, volatile organic compounds, and some semi-volatile organic compounds, permeate through the membrane and are trapped by the sorbent medium. The sampler comes in a sealed pouch, containing a glass vial with the WMS device and mini-pack, a wire hanger and nylon line, and PTFE tape for resealing the glass vial after sample retrieval. The mini-pack is a sorbent overpack to scavenge for errant chemicals before the WMS device is installed. Important things to note when unpacking the WMS: make sure the device stays away from potential sources of volatile chemicals including perfume and felt markers. Wear disposable nitrile gloves while handling the WMS device. Also, avoid touching the membrane prior to, during, and following deployment. When the WMS is ready to be deployed, remove the device from the glass vial. Insert the WMS device in the wire hanger facing downward. Secure the sampler at the desired location with the nylon line tying it to the wire loops. The WMS device can be hung indoors, outdoors, or hung within a dedicated borehole for soil gas collection. The mini-pack should now be placed in the aluminum pouch. Do not return the mini-pack to the glass vial. Once sampling is complete, retrieve the WMS device from the sample location and remove the device from the wire hanger. Place the sampler back in the glass vial and seal it with the cap and PTFE tape. Be sure the mini-pack is not in the glass vial, as the mini-pack sorbent could interfere with the collected chemicals inside the WMS device. Put the vial in the bubble pack and seal it in the aluminum pouch. Your sample is now ready to be shipped to the laboratory. Some of the advantages of the WMS include: the hydrophobic polydimethyl siloxane, or PDMS membrane, is well suited for humid environments. The device is insensitive to windy conditions and are beneficial for outdoor, subslab mitigation vent pipe monitoring, or soil vapor extraction system sampling. For sampling in soil gas, the leaking of air from the sampler are not a concern compared to active sampling methods, and no leak check procedures are required. The thickness and porosity of the PDMS membrane can be modified to vary the sampler uptake rates, so they are less than the lowest expected soil gas replenishment rate when sampling soil gas in low soil permeability conditions. The sampler can fit within a subslab vapor point for leak-proof subslab monitoring. Some limitations of the WMS are: for soil gas sampling, low soil permeability conditions can result in the uptake of VOCs in the vapor phase at a greater rate than the replenishment rate of VOCs from the surrounding soil. The sampler must be suspended vertically, so the sorbent within the vial covers the entire surface of the PDMS membrane. The saturation of the sorbent within the device due to exposure to high chemical concentrations over an extended period. Competition between strongly adsorbing VOCs displacing less strongly absorbed VOCs. Poor laboratory recovery rates from the use of a strong sorbent, with chemicals that are not completely released from the sorbent during analysis. When compared to thermal desorption, the solvent desorption method requires additional sample preparation steps with potential for analytical interference from formation of artifacts. Some components of this sampler may contain PFAS, which should be considered based on project data quality objectives. Some important takeaways about the WMS include: the device is versatile, compact, and easy to use without specialized training. It can be deployed in many locations discreetly and can handle ranges of moisture and VOC concentrations. Careful selection of sorbent types should be considered to ensure analysis is completed correctly and without complication. Reporting requires calculations to convert sample concentrations from mass to volume. Remember, you can learn more about the Waterloo membrane sampler and others in the ITRC Passive Sampling Update online guidance document.